All right, guys. So here we're going to be looking at the experiment itself for the conservation of momentum between two objects, and it's going to be inelastic collision where objects stick together. As you can see, the goal of this experiment to apply conservation of momentum to a collision to make a prediction about the outcome, then test our prediction. All right, so our two objects are going to be a blow dart and a low friction cart. And in the experiment, you're going to see that there are several trials. The first one is the demo, which I'm going to be using to demonstrate, and which you're actually going to be also going to be using to get some of the methods of calculating, for example, the velocity of the object before and after the collision. All right, so let's load this. Let's look at the experiment itself. So you should be able to see that object 2, which is the cart right now, is initially at rest. Then you're going to project object 1, which is going to be moving to the right, collide with the cart, stick together, and they're going to be moving after the collision together. That's the inelastic collision. All right. So break it down, we have two things. So if you go back, you can see, right, here's the object 1 moving, where object 2 is at rest, then collision, and then they both move after the collision. So if I have to then look at it in terms of my system, so then I can say that this is a system before the collision. So I can say that momentum of the system initially is momentum of 1 initial plus momentum of the 2 initial, which will be m1 v1 initial plus m2 v2 initial. The blow dart is my m1 moving at velocity v1 initially, and then m2 is my cart, which has no initial velocity. So then technically I can come back and set this whole thing to 0, and then I can say that initial momentum of the system is just in terms of m1 v1 initial. That's the initial momentum of the system. Mass of the blow dart times how fast it's moving, because the cart has no momentum initially. It's at rest. All right, so then if we look at, so this again, this is before collision. Let me also write that down. So this is before the collision. So this is before. Then we can have the momentum after they collide. So you can say, right, collision, and they move as 1 after the collision. So then what I can do here is I can write this as, all right, so I can say this is the momentum of the system after P final, whereas P1 final plus P2 final, but technically they're going to be moving together. So it's mass 1 plus mass 2 combined as 1 mass, then times V final, which is the final momentum of the system after the collision. Okay, that means conservation of momentum then tells us momentum before and after are exactly the same. Okay, that means we can assume that whatever I have here, so this is equivalent to the momentum after. That means this is momentum after, then it's going to be equivalent to mass 1 times the initial velocity of 1. That's the conservation of momentum. On the right side, I have momentum before. On the left side, I have momentum after of the system. All right, so let's go ahead and clear this. And then what you will do here, if at this first one, which is getting started module, you should be able to then learn about some of the ways you can do some measurements. So for example, how fast was the blow dart moving? See, it was launched here and moved, and you can see, right, it's moving at a constant speed and it hits the cart. Okay, how fast it is moving. So to do that, we can basically take this cart to be moving from position 1 to position 2. Let's say here I can say that this is position 1 and this is position 2 when it collides, and I can just measure the distance from position 1 to position 2. To do that, we can use one of the tools. Here's the tool. You take it, you put it there, and that should give you the position between point 1 and point 2, which is the distance that blow dart has to travel. All right. Now, if I take the timer and reset that, and then start the video, it will also give me how long it will take for the blow dart to go and cover that much distance. See, my zero starts from here. As soon as you can see the blow dart, and then you can see, right, it takes roughly 0.75 seconds. And the measurement is roughly 45, 46 centimeters. It means the distance is about 45, 46 centimeters. The time is 0.075. And what the first part pretty much tells you is that, can you verify those? So basically, what is the measurement of the distance that you see? So for example, right, it says, sorry, what distance would you see there for the distance that blow dart is covering? Okay, or let's say which frame is that, and also let's say how fast it's moving. Well, how fast it's moving will be this: speed is equal to distance over time. How far it moved and how long. That those two information will tell you how fast it was moving, assuming it's moving at the constant speed. That means you should be able to find this. And once you find that, then what they will give you here is, all right, so this is the equation for the velocity. And then what you have here is when you're given the mass of the dart, then you can find the momentum, which is m times v, mass times velocity. And units are gram per centimeter squared. That means you don't have to convert anything into kilogram and meters. You can just leave it in terms of that. And be also aware that you have plenty of submission. You get wrong, you can just go back and try again until you get it right. So obviously for submission in this case overkill, but you get plenty of submissions. Now let's see what we have. So for the next part, then you're going to be looking at actual experiment where you choose, you have to like your answers, and then you go to the next one, and then it says pick a trial that is not the one. That means something other than one. Okay, where you will be, for example, you can go 3. So it's the same thing. It's just, you're given the mass of the dart, you're given the mass of the card. And if you go, for example, see, let's say here 28.1 for the dart, 250 for the card. You go to a different one, well, you get different masses. That means the idea here is that you have option to choose any of the 11 trials or 10 trials, where the first one is a demo. All right, so what I'm going to do, I'm still going to use a demo to demonstrate that. But so that you have different numbers. So that means what you're going to do here is, once you choose, show me which one you choose, and then it says find the initial momentum of the dart. Now, how do you do that? Well, just like you learned in the first part, right? So that means you can see, right? Let's say, for example, if you choose trial 2, you're given the mass of M1 and M2, but everything else is basically the same. Okay, so right. So this is just the initial part. This is just the initial part. That means you're only looking at the collision, starting from that means not necessarily collision, but from the start to the collision, because you don't need anything else to calculate the initial velocity. But what you do here is you, again, use the, find the distance. You can say a little bit different, timer. And then what you have here is, you can say it's right away, you pretty much, you can say it as soon as you see the dart. Let's say, there you go, right here. I reset, and then I start the timer. So 0.0667. That will be your time for this trial. And then you have the distance. Use those. That means first find the speed, distance over time, then find the momentum, mass times the speed, or mass times the velocity. Okay, remember, speed and velocity for me is the same thing. Velocity is the speed and direction, but all of them are going to have the same direction. So, pretty much the same for us. All right, so that means this particular part gives you that. Choose a trial, find the distance, find the time, solve for the velocity, use that to solve for the momentum. Okay, and you can see, right, that's what you have. And once you have that, the question is that, can you predict the final velocity? Okay, so what you need to do here is you remember we talked about, right? M1 plus M2 times V final equals M1 times V1 initial. That means you are given M1, you are given M2, and right now you're going to calculate V initial, or you're going to calculate this quantity altogether, right? Part 2 over here, it's asking you to calculate initial velocity, and then using that to find initial momentum of the blow dart. And from here, all you have to do is just divide both sides by V final. Okay, so sorry. I apologize. Divide them by M1 plus M2. So once you do that, you cancel that. That means your V final. The V final is going to be momentum of the blow dart divided by their combined mass. Then you will have initial velocity. Okay. Once you calculate this, whatever you calculate for the final velocity of the system, then you're going to go and predict. So you're going to test your prediction. So you're going to log this particular answer. Then you're going to open this one, where now you're going to get the second part of the experiment. That means you're going to go the entire thing. So for example, if you chose 2, you're going to come back instant where they collide. See, before they start moving, then you take out the timer, take out, let's say, your ruler, and just measure, for example, 20 centimeters, for example, right? So you can look at in terms of what you have, right? So, and let's say 20 centimeter motion distance, and take out the timer, reset, and you can see, right? If I start, it's gonna tell me how long did it take for it to move. You can see, right? I'm using that yellow dot at the center. So, right, you can see, right? So right there. So now it's going to start moving. So, for example, I can reset here. And all right, so it starts moving until that yellow dot reaches 20 centimeters. And then I can stop and look at the timer, 0.2625. Then use those, distance divided by time, to give me the velocity. Once I have the velocity, then I can calculate the momentum. But remember, right, so at this point, we were asked to find the velocity. That means what you need to do is, again, distance after the collision divided by time, and you can choose anything you want. You can choose 15 centimeters if you want. But for example, final velocity will be just that, distance divided by time. Once you calculate that, then, you can, you should be able to compare to what you calculated in the previous part. Okay, and that's kind of the idea. Were you close? Were you not? So you can technically represent it in terms of percent, percent error, percent difference, in terms of, how far away they're from one another, and discuss it. Did you get a good experiment or not? But this is a good and, nice, good experiment that allows you to see conservation of linear momentum between two objects, in a perfectly inelastic or completely inelastic collision.